Today we're going to talk about function operations. Make sure that you've watched the videos on functions before you watch function operations. You already know what function notation is. You should know now that f of x is not the only way to write function notation. I can use whatever letter of the alphabet I want for f, with the exception of a couple like x and y. You wouldn't want to say x of x, right? So g of x, h of x, k of x, j of x, those are all fair ways to write function notation. So let's say that you were given two different functions, which is why we have to be able to use more than one letter. I can't say that both of these are f of x. I have to use different letters for my functions. So let's say f of x is 2x plus 3 and g of x, or a different function, is 8x plus 10. What do you think would happen if we had to add f of x and g of x together? We would simply take those two functions and add them. Remember, we would be combining like terms, so 2x plus 8x gives me 10x, and 3 plus 10 gives me 13. So f of x plus g of x is 10x plus 13. So let's have two different functions now. Let's say now f of x is x squared minus 7 and g of x is 3x plus 1. So if I have to add those functions together, remember we're simply adding the two functions, combining like terms, and I would get x squared plus 3x minus 6. What if I had to subtract them? Let's say f of x minus g of x. In this case, I want you to be particularly careful. Remember to put your functions in parentheses, especially in a subtraction problem. Because remember, when we subtract something, we might have to do a little bit of distribution before I can actually combine like terms. The first function, nothing's really going to change there. I'm just going to write down the x squared minus 7, but it's the second function I need to be careful of. I have to distribute that subtraction through the second set of parentheses, just like if I were solving an equation. So the negative times the 3x gives me negative 3x, or subtract 3x. And the negative distributed to the positive 1 gives me a minus 1, negative 1, or I could call it subtract 1. Then I can combine like terms, and I would get x squared minus 3x minus 8. There's one more way that f of x is used that we're going to learn today. Let's say that our new function f of x equals 4x plus 10. What do you think f of 2 would stand for? Notice how close they are, f of x and f of 2. What's different about the two notations? Yeah, this is saying replace x with 2. So I'm going to rewrite my function. F of 2 means everywhere I used to have an x, now I'm going to put a 2. So now instead of 4 times x, I have 4 times 2 plus 10. 4 times 2 gives me 8. I add 10 to it, and I get a total of 18. Let's hurry and do a couple more examples. I'm not actually going to test you for understanding yet. We're going to do that in class. Let's just do these as examples. So, first of all, f of x plus g of x. Notice I have 4 different functions up here, each with a different letter, so I need to be careful that I'm using the right ones. I need to use function f and function g. If I have to add them together, I have, oh, yellow's a horrible color on here. Hang on just a sec. 3x minus 1 and I'm adding to that x plus 7. 3x plus x gives me 4x, and negative 1 plus 7 gives me positive 6. This is my answer when I get those two functions added together. H of 3, this is telling me to use function h and replace x with 3. So now I'm going to take function h, which is x squared plus 2x, and now everywhere I had an x before, I'm now going to put a 3. It's an excellent idea to put that 3 inside parentheses. So now I get 3 squared, or 3 times 3 gives me 9. 2 times 3 gives me 6, and 9 plus 6 gives me 15. Now I've evaluated h of 3. Let's try f of x minus g of x. F of x, remember, is 3x minus 1. Be really careful when you subtract, because you definitely want to make extra sure that that second function's in parentheses. The first function it won't really matter with, but remember we have to distribute the negative through the second set of parentheses. 3x minus x gives me 2x. Negative 1 minus another 7 gives me negative 8. And now I've simplified f of x minus g of x. Next, let's look at j of 2. That tells me use function j, which was x squared plus 5, and replace our x with a 2. 2 squared, or 2 times 2 gives me 4, plus 5, I get 9. Next, let's try g of x plus h of x. G of x is x plus 7. I'm going to add h of x, which is x squared plus 2x. With addition, it's simply a matter of combining like terms. X squared does not have a like term, so it gets written down. 1x plus 2x leaves me with 3 x's. That takes care of those. And 7 I'm going to write on the end. Here's my simplified addition problem. And last but not least, let's take a look at, let me hurry and get a color here, f of 3 minus g of 1. This one tells me I have to do 2 different substitutions before I can subtract. So I'm going to do f of 3 gives me 3 times 3 minus 1. And I'm going to subtract g of 1 means 1 plus 7 instead of x plus 7. 3 times 3 gives me 9 minus 1, and I'm going to subtract 1 plus 7 is 8. 9 minus 1 gives me 8. Subtract another 8 gives me 0. This is not your actual assignment. Sorry, I forgot to put something in there. But remember to write down any questions that you have when you come to class so that we can discuss them and possibly go through some more examples if you need it. Have a great day, and I'll see you next class time.